on my portfolio. I may submit the portfolio tomorrow for my teaching practice. Okay. What we are going to do now, we're going to do weight, energy, and power in this term. So this whole week we're going to be doing weight, energy, and power, which is based on the displacement. So when you are dealing with the weight, for example, for you to do a weight, there must be a displacement. So you cannot say that you have done the weight by just lifting this towel up like that. All together. So if you just lift this towel upward, can you tell someone that you have done the work? Huh? If you lift just a towel upward, you pick the towel like this, and then you lift it upward. Can you tell anyone that you have done the work? Huh? Or if you jump like this, can anyone not tell you that you have done the work? No. There's no way to get it. Yes. So you cannot define the weight when someone just jump like this. So when someone jump just like this, you cannot tell that, okay, this person did this amount of weight. Okay. But if I'm standing like this and I move from one point to another point, you can tell that no, he has done a certain weight. Are we together? Yes. So a weight is done if you move from one point to another point. But if you just keep on standing like this, how much is the weight done when you're just standing like this? No. Can you define a weight? No. So you cannot define the weight which a person has done. Even when you are cooking something, right? If you just put the water and then the water in the pot and then you don't switch on the stove, and then when you come back and then you just find out the water level is still on the same position. Can you tell whether there's something happened or something didn't happen? What can you tell about that water, the water level? Nothing. So you say that there's nothing that happened. The same applies to weight. So a weight is done when there is a displacement. So, for example, you do have object here like this, right? So if this object moves from point A, so this is point A, then to point B. So moving from point A to point B, this tells you that there's a weight done. But if the object remains on the same position, it tells you that the weight which is done by the object is 0. Are we together? Yes. So because everything is balanced. So in the objects which are stationary in this way, we say that the weight which is done on an object is 0. So here we have 0 weight again. So, and then from the second one, if the object moves from point A and then coming to this side, with the force which is F. So in this case, we can tell that we are having an object and then which is being pulled by a force again. So a force needs to be applied on an object in order for it to accelerate, are we together? Or to move. So for this object to move from this point to this point, there must be a force. So what is force? How do you define force? Anyone? How do you define force? Or what is force equal to? F equals to what? Ma, which means that force is the product of what? Mass and acceleration. Again. So when it comes to weight, weight equals to what? F, not F net. It's equals to F delta x cos theta again. So, but in the case whereby you are not having a displacement, where you are not having an angle, so the weight is going to be F delta x again. Sorry, in the case whereby you don't have an angle. So in this case, So you do have a weight, and then force, and then delta x. So what is delta x? Is the distance, yeah? So in this case, here is where you be having your displacement. Are we together? Yes. So now, what is this theta? So this is the angle between displacement and the force. Are we together? So you are having a force F here, and then also a displacement. So, but we don't know how much is the displacement. Are we together? So in this case, we say when W stands for what? Work done again. And then you do have delta x, we say is what? Distance. Sorry, it's a displacement. Displacement. And then you do have theta. What is theta? Theta is the angle between what? Force and displacement. So, in this case, for you to be able to find the angle, let's say in this case, what is the angle between the force and the displacement in this one? The angle is how much? Remember the statement said that theta is the angle between force and the displacement. So, what is the angle between displacement and the force? The angle is? Theta. The angle is 0 again. So, in this case, the angle is 0.
There's no displacement.
Yes. So the reason I already mentioned that the angle between defines theta again. Did you brought your books? Textbooks?
Yes.
Why? Or is it because it is the first day of reopening? Okay. Now I understand anyway.
We are still adapting.
I hope very soon everyone will be used to this color. So, a weight is defined as what? Is the product of what? Let's look at this one. So by looking at this formula, weight is what? Is the product of force and displacement. Yeah? Okay. So now in this case, how do we calculate a weight? How do we calculate a weight? So let me just do like this. Let's check on the page, what page, those who are having a book, check page 168. Let's consider example number weight example there, refer to figure 4.6. So calculating weight jump. Okay. Now let us look at this example next. You should calculate the work done by the force by 100 Newton force which acts at 20 degrees to the horizontal. Right. The force displaces the object 3 meters along the horizontal frictionless plane. What does the word frictionless plane tell you of? The friction is what? Friction equals to 0 again. Right. And then from this one. So in order for us to calculate the work done by a force or a friction force, which formula do we use? What is the formula which you can use to calculate the work done by a certain force? Huh? Work is equal to what? Work equals to F delta X cos theta net. So this is when a force is applied at a certain angle again. So in this case, we do have the force F here. Force which are given is equal to how much?
100 Newton.
200 Newton. Ne? So now, in this case, we need to find the work done by 100 Newton. So work done by 100 Newton. So, if you check before you go any further, ne? So the object move from this point here, it moves for a 3 meter. That's why you find that it's here, and then secondly, you have it here. Right. But in some case, you find that you're not going to be given an object moving from this point and then to this point. You're just going to write the meter here and you got the second block altogether. But you need to know that the object is moving from one point to another point, which is from this point to this point. If they don't give you the object to be, like we are having here, in this case, altogether. So, now, in this case, how much is our force? 100 Newton. And then how much is delta x? So we are going to multiply by 3. How much is theta? So theta is 20 degrees. So press your calculator. How much do you get? 281,9077,862. Right, which is approximately 281,91. Ne? And weight is measured in what? It's measured in joule altogether. So weight is measured in joule. So you need to know that all the time the SI unit for weight is joule. So then from here, we do have so this work here, is it positive or negative there when you calculate? It's positive, ne? So which means that there is a work which is being done altogether. So now from there, if you are having an object, ne? So we are done with this one. The answer, the work done by 100 Newton is how much?
281,91.
So, and then how about the other forces, frictional force? 0, né? And then we do have a normal force and gravitational force. How about that? So now, the question becomes, does normal force and not exactly normal force, that's perpendicular forces to the ground apply exact force on a horizontal plane. So this is the question. Does perpendicular forces exert a force on a horizontal plane? I'm sorry, on an object which is on a horizontal plane. On a horizontal plane objects. Okay? So now let's consider the diagram like this. Let's consider objects below. So let's consider the object below, which is this one here. Right. So, what is the free body diagram for this one? So what are the force diagram? So what are the forces acting on this block? We have the normal, which is pointing what? Upward, which is perpendicular to the surface, which is Fn or just N. Right. And then you do have what? Gravitational force, which is F, G or weight. And then we do have force going the other direction. This force is what? We can say it's what? Force applied. So, and then here we have what? F, friction, or frictional force again. So now, the angle here, we find that here is 90. And then here is 90. So now when you are measuring angles, so remember this one you are going to start from 0 degree, and then here you are having what? 90 degree. This side you have what? 180 degree, and then this side you are having what? 270 degree. Okay. So when you are measuring, you measure from this side going the other way, which is anti-clockwise. So when you measure angle, you measure anti-clockwise in this case. Okay. So there may be having a distance here. So this is a distance. So which is delta x. Say from this point to this point, you do have displacement, which is delta x. So you measure from this point going the other way around. On the case like this. So let's calculate work done by each force. Work done by each force. So we now know how to find the work done by the applied force. So let's start by work done by F applied. Remember delta x is here in this point. Again. So now, weight equals to, what is the general formula for weight? Weight equals to what? F delta x
Cos theta.
cos theta. Again. And then from there, you are having F. How much is the force? Force, we are not given the value, ne? So we only have F applied, ne? Again. So delta x, what is that? Delta x, ne? There is nothing again in this case. So which means that we are just going to put delta x again. But if you are given the value, what are you going to do? If you are given the value, what are you going to do?
Substitute.
You are going to substitute again. So now you have cos theta. How much is theta in this case? Angle between applied force and delta x is 0 degree. And then press your calculator there. How much cos of 0 is how much? Cos of 0 is 1. Ne? So n cos of 0 degree gives you positive 1. I want to get it. So therefore, F applied. So this is the force done by applied. Ne? You must write this. Delta x. Right. This is the answer in this case. Okay. So the answer is positive. And then work done by Fn or normal force. What is the work done by the normal force? So now first of all you need to tell us what is the formula for work done. What is the formula for work done? Work equals to F delta x cos theta all together. Cos F delta x cos theta. Next, let me just try to highlight this one before you take part. So in this case, how much is theta? The angle between the angle between delta x and Fn is how much? 90 degree. Ne? So press on your calculator. Cos of 90 is equal to what? Cos of 90.
0.
So cos 90 degree equals to
0.
0. So which means that the work done by normal you can look at
0.
So the work done by normal gives you equals to 0 joule. Right. So no work is done by this force again. So now we do have the frictional force here. Right. So because we do have the frictional force, what is the angle between delta x and the frictional force here? So this is for work done by F friction. So work we say equals to F delta x cos theta. So whereby here you are looking for work done by F friction. So in this case, we say that F is how much? We just have F friction. Then delta x cos of 1/8. Again with that, theta is how much? 1/8. Ne? Cos of 1/8 is
-1.
okay? And cos 180 degree equals to -1 again. We are almost there. So, which means that the answer is going to be negative F friction delta x net. So the work is negative altogether. So let's do the last one, which is the work done by gravity. Net. So for work done by Fg. So work equals to Fg delta x cos of, what is the angle between delta x and Fg?
90.
Huh? The angle between Fg and delta x?
360.
360.
270.
You measure from this, next, like this. Coming here, how much is it?
270.
So the angle is 270 degrees. And cos of 270
Is equal to 0.
270 degrees equals to 0. Next, therefore work done by FG, you can only get 0 joule. Altogether. So that's it. So you get your homework on social media. Thank you. And good to know.